The last topic in our section on arrays is random numbers. Random numbers are very handy to fill up arrays with information, so we don't have to type all that in, and we can learn then to manipulate arrays and write other programs using those random numbers. So we call it a pseudo-random number generator because only nature really provides random events. The random number generator is actually another program in there, an algorithm that's used to generate the random numbers that we use, but it's a pretty good algorithm, right? When we want to use a function to generate random numbers, that function is called rand, rand. It's defined in the standard library. So whenever we use it, we're going to have to include stdlib.h, right, as a header file. All right, so it's prototype. The name of the function is rand. The void means it doesn't expect us to pass any information to the function, and it's going to return an integer value. Right, so it's guaranteed to return a number between 0 and rand max, where rand max is a preprocessor directive that's defined in that library. Right, it can vary by implementation, but it should be at least 32,767. Right. What we'll want to do is sometimes we'll just generate any random number, and then sometimes we want random numbers in a specific range. And there's a formula that we can use to guarantee we get the range that we want. So we're going to take what's known as the high value, subtract the low value from it, and add 1, and create a number value. So here where this says rand mod number, if you substitute in for number high value minus low value plus 1, then you add low value back onto the range, you'll always get the range you want. But let's take a look at some actual mathematical examples to see how that works. Right, so we want to generate a random number in the range from 0 to 10. Our high value is 10, our low value is 0. So we call the rand function. So here's the formula in green, right? Rand is the name of the function, empty parentheses. We're going to mod that by high minus low plus 1 and add low back. So high was 10, low is 0. 10 minus 0 gives us 10, plus 1 gives us 11. If we mod any number by 11, we get a range of values anywhere from 0 to 10. Right? The possible remainders when you mod any number by 11. So remember, the mod operation divides by 11, well in this case 11, and returns the remainder. Right? So the possible remainders whenever you divide a number by 11 are the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? And then we add the low end back onto this. We add 0. We'll be guaranteed to get a number in the range of 0 to 10. Notice those endpoints are inclusive, both the 0 and the 10. Right? When you're looking at this formula, you're probably saying, well, I don't need to hard code in a 0, and I don't need to add a 0 back. And typically, no, if we're hard coding in numbers all the time, you wouldn't. But high and low, we're going to find are often variables. So once you learn this formula, if you use this formula, you can't go wrong in generating your range of random numbers where the endpoints are inclusive. Let's look at another example. If I want to generate a random number in the range of 3 to 106, 106 is our high, 3 is our low. So here's high minus low, add 1 back to it, and then we're going to add low on, or add 3 back to it. So let's take a look at the order of operations. 106 minus 3 is 103. 103 plus 1 is 104. The mod operator has a higher precedence than the addition, so this takes place. So this is going to return any number between 0 and rand max. But when we mod it by our value of 104, that means we can get numbers anywhere from 0 to 103 as a remainder. So if we get numbers from 0 to 103, but we want 3 to 106, if we add back the low range, so 0 plus 3 gives us 3. The upper end of that range was 103, so 103 plus 3 gives us 106. Right, so try some other practice ranges on your own, filling these numbers into the formula so you can convince yourself that that formula is correct. Right. Now here's the thing, when we call this rand function, if we don't initialize it to some sort of specific seed, we're going to see that we get the same set of numbers every time we run a test program. And I want you to think about why that may or may not be a good thing. And in this case, why is it a good thing? On the next slide here in the lecture, I've actually got an example where we're going to generate random numbers. So we want to run this program multiple times, and we want to see if we get the same list of random numbers. So let's just escape out of that. Here's the same example in code blocks. Notice here, I've included the standard library, standard library.h, because I'm calling the rand function. So puts, remember, put string is just going to write this string to the screen. Puts automatically appends a new line. So with my escape sequence in here, I'll actually get a blank line after that on the screen. We're just going to run through this 5 times so we can generate 5 different random numbers. I'm using a field width of 7 here to give some room in between them to display them. So if I call rand, remember rand, this function. So call the function, empty parentheses here. It's going to return a number between 0 and rand max. Right? It will substitute that integer value in here for my %70. Let's just go ahead, and I think I already built that earlier. Run that. All right, so our random values are 41, 18, 4, 6, 7. Right. If we use, let me maybe bring up the snipping tool here. All right, let's just go ahead and snip out this little image so we can save it. Right, let me minimize that. Let's hit the enter key. Let's run this again and see if we get the same set of random numbers. All right, so I believe we did. If we pop this back up here, right, we can see that the numbers are exactly the same. 41, 18, 4, 6, 7, 63, 34, 26,500, and so on. Right, and no, I don't want to save that. Let's see if we run it again and again. Or I won't run it again and again, just one more time. We get the same set of random numbers. So my question is, why is that a good thing? Well, if we're using random numbers in our program and we need to test to see if our logic in our program is correct, if we get a different set of random numbers, especially if we're doing a lot of calculations. If I'm doing a lot of calculations, we're going to have to go through and manually verify that the set of random numbers we use for test data is producing the correct, our program is producing the correct output for those numbers. So by using the same set of random numbers over and over, we can then test our program repeatedly with that same set, know that our program is working as we expect it to, before we go ahead and do something called seeding the random number generator. Seeding the random number generator will then actually let us create different sets of random numbers every single time our program is run. Right. So that's what we'll do. We'll initialize the random number generator, and that's called seeding. So there's a function called srand. We're going to pass to that an unsigned value, so an unsigned integer, right? This is the parameter name is called seed. We'll just pass it an unsigned integer. It won't return any information, but what it does is it will use that number to start the algorithm. It will be a seed to the algorithm, and then when we run that, we can actually get a different set. Now, the thing is, if we use the same seed value each time, so 2 different initializations, if I seed it with a number 1, I'm going to get a different set of random numbers than if I seed it with a number 2, and a different set if I seed it with a number 3 and 4, and so on. Right? The only thing we do get, this tells us that if the seed value here is set to 1, the generator is reinitialized to its initial values and produces the same values as before any call to rand or srand. So if we call srand more than once in our program, we can restart the same sequence of numbers if we need to. Right? What we normally do is we use a function in the time library. We use the current time, which is a little bit more random, so that every time our program runs, we basically will end up with a different set of random numbers. Right, so here's an example here of some different set of random numbers. Right. So let's just pull this into code blocks. And see how it behaves. All right, so we're using standard IO for the printf and the puts. We're using standard library for the call to srand and to rand, and then the time library because we're going to call this function time. Right. So here in main, I'm going to seed the random number generator by calling the function time So this function does require that we pass this null to it. Null is defined in C. Right? We pass null to it. Think of null as nothing or 0. Right? This is going to return a time since our computer started running. Actually, let me look that up, because it used to return a time since some date in the 1970s, I believe. But it's going to return a very unique time. We'll see the random number generator with that. And what it returns is an unsigned integer, so it's the right data type to pass to this function. And we'll just print out our list of random values. So that's the only difference in this program from the previous one, is that we're now calling srand. All right, so now if I build and run, notice before my first number was 41, right? Now I get a different list of numbers here, right? 1270 is our first number, 20. Let's just run it again. All right. Once again, 1332, 4433, different number, right? And once again, we run, right? Different set of random numbers there. So by seeding that, right, we get these different sets of numbers. The most common method is to use this time function. In order to use the time function, you have to pound include time.h. Time requires that we pass this value of null to it. It returns an unsigned int. Right. Actually, time underscore t is a data type. It's an unsigned int. Right. srand expects an unsigned int. It seeds the random number generator, and we get that behavior of different random numbers every time we run our program, which is what we want when the program is running in production. We generally don't want the same set of random numbers. But random number generators are used in games quite a bit. Right, and you don't want the same sets of actions time after time. Okay, so that is the end of our discussion on random numbers. You will be using that in your homework. Right. Check out some of the other videos that I'm going to make with some example problems using random